We're going to look at adding and subtracting matrices, and the key to adding or subtracting is that the matrices must be the same size. Okay, and you'll see why that is. So let's jump right into an example to see how this is done. So in this example, you can see we have a 2 by 2 matrix plus a 2 by 2 matrix, and we need to determine what that is. And so these are both the same size, so we can add. Okay, so all we do is we add the corresponding entries. Add corresponding entries. So first row, first column is going to be added to first row, first column. And of course, 1 plus 5 is 6. So our new matrix in the first row and first column, we're going to have a 6. And then we're going to take first row, second column plus first row, second column. Negative 2 plus 6 is 4. And so we get first row, second column, and the answer will be a 4. And so on. Negative 3 plus negative 7 gives us negative 10. And 4 plus negative 8 gives us negative 4. And so the answer is another 2 by 2 matrix. So when you add two matrices of the same size, you get a new matrix of the same size. Let's see a couple more examples. Now we look at the same two matrices, but we're going to subtract the second matrix from the first. And to do that, we do it the same as addition, but instead of adding the entries, we subtract them. So the first row, first column, we're going to take 1 minus 5, which is negative 4. And that's going to be our first row, first column of our answer matrix. Then we have negative 2 minus 6, which is negative 8 for the second row, or first row, second column. Then we have negative 3 minus negative 7. That's negative 3 plus 7, which is 4. And that's going to be our second row, first column. And finally, we have 4 minus negative 8, which is the same as 4 plus 8, and that is 12. So we end up with another 2 by 2 matrix where the entries come from subtracting corresponding entries of the original matrices. Let's look at another example involving some scalar multiplication as well. Okay, so here we need to determine 2a minus 3b if matrix A is given here and matrix B is given here, okay? So we need to figure out 2a minus 3b. So that's what we're going to start with. 2a minus 3b. That's the same thing as the scalar 2 times matrix A, which is written here as 4, negative 3, 1, minus 3 times scalar multiplication again, times matrix B, which is 0, negative 5, 2. It's very much like the order of operations. You multiply before you subtract, and we should already know how to do scalar multiplication. I'm going to multiply 2 by this matrix, giving me a new matrix that is 8, negative 6, 2. Scalar multiplication by 2. Minus and I'll multiply 3 by this matrix. You could multiply -3 by the matrix if you want, but if you do that, you're going to add in the next step instead of subtract. So I'm just going to multiply the 3, and then I'll subtract the 2 matrices. So scalar multiplication by 3 is going to give us 0, -15, 6. And now we already know how to subtract matrices. I'll take each entry from the first matrix and subtract the corresponding entry in the second matrix. So I'll have 8 minus 0, that's 8. Then I'll have -6 minus -15. That's the same thing as -6 plus 15, which is +9. Then I've got 2 minus 6, that's -4. So the final answer for 2a minus 3b is this 1 by 3 matrix. Okay, now if you do run into matrices that aren't the same size, you cannot add or subtract them. It's not possible. So this is all about adding and subtracting. We threw in some matrix scalar multiplication along with it so you can see how to do that, as well as a little bit of notation. Oftentimes matrices are denoted with capital letters like capital A, capital B. So sometimes they're written that way to keep it shorter.